Alrighty, so question number 1, multiple choice. By the way, there's a little blank there. That's the place for you to put the answer, if you wouldn't mind. Okay, it's easier to mark. Correct answer is C, inverse. There was the odd person that said quadratic. Quadratic would not look like that. Quadratic would look like this. Whoa, that's not good. Not sure what's up with the smartboard. Quadratic would look like this, right? If it was the other side, then it would continue, it would eventually go up. Okay, it wouldn't be flat like that. So that's an inverse one. Describe in your own words what is physics. Some people basically give it to me verbatim, or they tried to put it in their own words. Some people just were like, it was way out there. It's the study of matter and energy. I'm sorry? Yeah, sure. The study of matter and energy and the relationship between the two of them. Is the correct answer from the notes. This was a simple, can you read a graph and use it kind of thing. 65 cubic centimeters. Why is this not working? I shouldn't have to. I should be able to pick it up. It always works that way. I'm gonna have to restart. Okay. So yeah, 65 cubic centimeters, right? Is that what I said?
Yeah.
That doesn't sound right.
Yeah.
Oh, it's there. Okay, so there's 70, so 65 is right about there. I took anything around 20. Okay, can you read a graph? 3 skills or attitudes necessary to study physics. Explain how each one relates to the study of physics. If you were at all close, I gave you 6 out of 6. Okay, the vast majority of you got 6 out of 6. Those are freebies, by the way. You will not see easy questions like that ever again. Tests will get harder. Complete the sentence. Okay, here's another rule. Just because there's a little tiny blank like that doesn't mean your answer has to fit in there. You will notice there's a large amount of white space down here. That is where your answer should go. Although I will say, agree with you, okay, over here I want, yeah, okay, I get you, right? Yeah. So scientific model is a conceptual representation of something that we can't see, or it's too big, or it's too small. It's a conceptual representation of something that helped us understand it. Give an example of a scientific model. I saw things like a globe, the solar system model of the universe, all those kind of things. Okay, most people did okay there. Explain why your example has changed over time. It does not say explain how it has changed. The globe has changed from a flat Earth to a round one. That's how it's changed, but why? Because we learn new stuff. That's the basic answer. You could have this. You could have any example that you wanted, and the correct answer for the last part is because we learned new stuff. We learned something new about it, so we had to change the model. We had to adapt to our current observations, if you want to be a little bit more verbiage. Okay, number 6 starts off kind of easy and becomes progressively more challenging. What is a scientific theory? It is a large, encompassing statement. It could even be a document. It tries to explain why something is the way it is, or why something happens the way it is. Right? It explains natural phenomena. It could include models and laws and presuppositions and a whole lot of stuff. Give me an example. Theory of evolution, climate change theory, Big Bang theory. If it ends in the word theory, it's correct. You cannot make up your own theory here. What is the difference between a robust theory and a speculative theory? Robust theories have lots of evidence. They are widely accepted by the general science community. Speculative theories are more guesses, very little evidence, not generally accepted. They are working their way towards becoming robust. If you use the word prove in this question, you are treading on thin ice. Okay? Very, very thin ice. Explain the difference between how we use the word theory in common use and in the scientific sense. Well, in the common use, theory really means just a guess, right? No proof. Now, if you put proof in quotations, then you're okay. And in the scientific sense, right, a theory is an explanation for something. Generally, there is some evidence to support it. Careful with the word proof. Evidence to support is a better statement than proof. Why is it dangerous for politicians to not understand the difference? Well, because politicians do what? Control the money. Right there is good, I'll grab it. Thanks. Politicians control the money, and they also make decisions. And if they don't know the difference, they can be making decisions that really aren't based on evidence. They could be making bad decisions. Shocking. Politicians making bad decisions. Okay? This is a tough question. You'll notice the question is why. Okay? Quite a few people got it. There was one. Liam, did I write really good on yours? Can I read it? Is that going to be... This was really good. I want to read it for you here. Because they have the power to make decisions about how society will cope with things like global warming, overpopulation, the disappearance of bees. And if they believe something is just a theory, it could influence them to dismiss the problem, which is in fact a very real threat. Politicians need to accept these problems and deal with them, and most likely vastly improve their levels of education. Oh. That's pretty good. Yeah.
Going to get on the test or
That's a good answer. That's the level of answer I'm expecting. You guys are smart. Show me.
That was like a 6-mark answer.
That's like AP answer.
Yeah. Show me. Show me you're smart. You are. Doing it at lunchtime wasn't so smart. What's a scientific law? A law is a regularity or pattern that we observe in nature. Something that we see always happen. Give an example of a law that was discussed in class. Most people put the when I throw the tennis ball up, it comes down law. You could say the law of parsimony, although, you know what? After did you have that in here? I thought to myself, you know what? I don't know if the law of parsimony is actually a law. Does it always happen? Is the simplest one always the... Well, maybe. I don't know. I kind of debated that a little bit in my head. Okay, number 8 was the Excel one. I was very pleased. Most people did it fairly well. Not one person had to handwrite their name on it. Thank you all so much. Finally, maybe I've got class to do that. Did you?
Yeah.
On that?
Well, disappointing.
I also would like things labeled too, by the way. Okay, number 9. Suppose your teacher tells you last August late one night he saw lights moving in a farmer's field. He claims it must have been a UFO hovering and moving about the field. If you were to apply the law of parsimony, what might you conclude and why? Joey, go ahead and read yours. You got a laugh around the dinner table last night, so go ahead.
It might conclude that either it was some kids playing tricks or Mr. Bennett was seeing things because of his concussion.
See, you got a laugh last night, you got a laugh here. Okay, well, Brian, what does your dad do in August and September? Out in the field, at night. Well, he might, I don't know. He harvests. You guys all live in a rural community. Farmers harvest in the fall. You've never seen combines out in the field after dark? You really got to get out of the city more often. Yes. If you were to apply the law of parsimony, you might conclude that it's the farmer out harvesting. Right? The law of parsimony says what? The simpler explanation is more likely. Right? How many assumptions do you have to make? You have to assume that it's A, the farmer, and he's in his tractor, and that's about it. If you assume it's a UFO, then you have to A, assume that there's life forms on other planets. Quite likely, by the way. They found water on Mars. B, they travel all the way here. And C, they're running around that particular farmer's field. Those are a lot of assumptions, and some of them are kind of a little bit stretched. The law of parsimony would state that it's quite likely to be farmer and his tractor. All right, now, coming, a reference line. Very good question. We'll get to that. Draw a scale diagram of the vector 150 kilometers per hour at 25 east of south. East of south. So you should have a reference line that goes south, because you have to measure from it. How can you measure if you don't have anything to measure from? Measure from a reference line. 25 east of south. Which way is east? So this should be 25 degrees. You should have a scale which always begins with 1 centimeter. How many people remember me saying your scale must start with the phrase 1 centimeter equals? Thank you, Brandy. I know that I said it. If you did not do it that way, I shake my smartboard marker thingy at you. It must start with 1 centimeter equals. It must. There is no other way to do it. And it must be something like 30 or 50 or 10 or whatever have you. And it's kilometers per hour. Yes, 1 centimeter represents 30 kilometers per hour. It's a velocity vector. You must have per hour there. Details matter. If you're sending a mission to Mars, you better make sure you don't screw up the units.
Didn't like NASA crash $1 billion unit?
Yes, they did, because someone forgot. They were building parts in Europe. They're working with scientists in the United States. They forgot the scientists in the United States were working in imperial units of feet and inches and pounds of thrust, and I'm going to Europe and using the metric system. Whoops, big screw up, $8 billion later. Units matter. Get them right. Okay, so this should be, in this case here, because it's 30 kilometers per hour, this would have to be how many centimeters? 5 centimeters, and there must be an arrowhead on the end. Details matter. Do it right. Good? Add the following vectors. Show work. Now, I cringed when I saw this question because, I screwed up. Because I really, no, maybe this one wasn't supposed to be done by scale. But anyways, it's 60 west and 60 north. So you can do a scale. 1 centimeter equals 10. But you should realize west and north, hey, I can use Pythagoras, right? So west, 60. North, 60. Resultant here. Notice that it doesn't take me long to label my diagram. You should do the same. Quit being lazy. Put a 60 and a 60 and put an R there. So I know that you know what you're doing. Okay? I'm going to start being stickier on this stuff. Details matter. Oh, by the way, this should be 1 centimeter equals 10 meters.
On mine you wrote not needed when I wrote that.
Yeah, it's not needed. Why not? Because it's a right triangle. Right? So you don't need it. I don't think I directed for it. No. 60 squared plus 60 squared. See how I'm showing my work? I jump right to this step. Is that okay, do you think?
Yes.
I think we're all big boys and girls. We can do 60 squared is 3,600, and another 60 squared is another 3,600, and add them together and get this. I think that's a good compromise because it tells me that you know how to do the math here, and you can sort of save a step, and you write R as your answer. I think that's an appropriate level of detail for grade 11 physics students. If you want to give me a little bit more, be my guest, but don't give me any less than that. I don't just want R equals 84.9. I don't just want that. I need more. 84.9 what? Meters. You'll also notice that I've got kind of like formula, math, answer. Notice that the equal signs, they may not line up perfect, but they're kind of close. I see sometimes stuff like this. See if I can do this. I see stuff like this. Whoa. I get like this, and I get Exactly. I see answers like this, where like it's just all over the place. Yes, jigsaw puzzle. No, no, no. Don't do that. Show your show your work means organize your solution properly. And I might even make you redo things if you can't do this. It is important. Do it right. I'm sort of the Mike Holmes of science. Do it right the first time. Am I done? I'm not done. I need an angle. Many, many people left out the angle and got confused with how to show this work. Man, that's annoying. Put in a theta symbol where you're showing me the angle is. And then you write something like theta equals inverse tan, opposite over adjacent. In this case, it's going to be 60 over 60. Now, here's the part that I regretted because they're both equal to 60. Most people should know that that's a 45-degree angle, right? And then you don't have to show the work. Now, that's going to be west 45 north. And yes, the west and the north are important. If all you write is 45 degrees, that's not good enough. Okay? It tells me you probably didn't do enough practice questions and didn't check your answers. You probably just thought, I get this, I'm just going to go with this. Not going to be good enough anymore. What does it say right there? Do by scale drawing. I want you to look on your sheet. Do you have the words not an RT triangle on there? Do you have the words not an RT and a little triangle sign?
What?
Some of you might have that. What does that mean? It's not a right triangle. Actually, this one is, isn't it?
Yeah.
Jeez, I hate that when I screw that up.
They both got confusing. Yeah, they both are rectangles.
Yeah, this one is. I know. Jeez, I hate when that happens. I got my test program just generates these numbers randomly, and it, yeah, so you got lucky. It's the right triangle. West of south, 130 west of south. But you still have to do my scale drawing here. So I needed a scale like. Yeah, I gotta restart this so that it stops doing this. 1 centimeter equals maybe 10 meters, something like that, right? So west of south, there's south. That has to be 45 in there. That's going to be 13 centimeters. And then from there, I'm going west of north. Reference line north, 80. So something like, yikes. Not quite. Right? Measure. Which angle do you measure? You do not. I found quite a few people did this. You do not measure this angle here. Why not? Because you have to measure from north or south or east or west. Most likely you're going to measure from north or west. Okay? You cannot measure that angle in there. If you use tangent, you're going to have to make some adjustment there. The correct answer is 152 meters at west, 14 south. Okay? Approximately.
What? Oh, I really got to
Okay? Subtract. Now, I have to say, you guys probably did it. Make me feel any better? No. Okay. Subtract this one minus this one, right? So, north 35 east. North 35 degrees to the east, 60 centimeters long. And then from there, now I go minus west 35 south, but I flip that. So now it's going to be, instead of west, it's going to be east 35 north. East is to the right.
No way.
35 north is going to be like this. Okay? So from here, it's going to be like, I got to go east 35 east and then 35 north. So it's something like this. Am I right?
Yeah.
Yeah. And then your resultant, let me just erase that last bit up here. Okay, so my resultant is from like here to there. You're going to measure that, right? And your R value is, I get 187 meters. Now, what angle do you measure, Caitlin? Maybe you should be watching more closely then. You're not going to find the answer in his eyes.
But you could have.
You should measure that angle there from north. I got 49, right? That's going to be north 49 east. From the north, measure 49 degrees east. Okay? Look at yours. See what you did wrong.
Yeah.
What's the difference between speed and velocity? Speed is a scalar, velocity is a vector, which means that velocity has a direction, speed does not. And the last one, what is the displacement? I couldn't have said it's subtraction. I couldn't have, unless I said subtract these, I couldn't have made it any easier. It's going from an initial position of 7.5 north to a final of 7.5 west. Displacement is final minus initial. If you write that on your paper, you say to me, Mr. Bennett, I know this, and I know that it becomes a subtraction question. And then I look at things a little more carefully. I see some level of understanding. I look for marks. Write that. It's important. The final position is 7.5 west. The initial position is 7.5 kilometers north. You have to subtract it and go south. So once again, I've got the numbers equal to each other. That's terrible. There is my displacement. That diagram is worth the mark. I need to see it. I need to know that you get vector subtraction means something. Then you write b squared equals 7.5 squared plus 7.5 squared. B equals square root of whatever that is, 112.5. Displacement, 10.6 kilometers. This angle, once again, here is going to be 45, but you really should show me that you know how that is calculated. Show me the money. Inverse tan 7.5 over 7.5. That's going to be west 45 south. The whole thing was out of 41. Please add it up again. Double check. Double check my math. I've been known to make mistakes before. Here's what I'd like you to do. I'd like you to take your cheat sheet, and I'd like you to take your test. I want you to take a blank sheet of paper, number it on the left-hand side, 1 to 15. For each question I wanted that you got wrong, I want you to write down what you did wrong, what you have to do to make it right on the exam. Because guess where I get exam questions from? Ooh, exactly. Okay? Will you see these again? Yes, on the exam. So you're going to spend the next few minutes making a little note of what you did wrong, what you need to learn how to do. I need to learn vector subtraction. I need to do this. I need to do that. I need to learn when to use right triangles and when not to use right triangles. Take a few minutes and do that.